Hello everyone, and welcome back to another video. In this video, we're going to talk about volume and we're going to talk about surface area. And we're going to focus on geometric solids. Geometric solids are three-dimensional shapes that are bounded by surfaces. So we're thinking about solids that are like rectangular solids, so maybe the volume of a box, or a sphere like a ball, the volume of a ball, or a cone or a cylinder. So a cylinder, maybe like a Mountain Dew can or some kind of canned vegetable, and then pyramids. Volume is the amount of space that's occupied on the inside. So you could think about like if we're talking about a can of vegetables, how much liquid can I put in there? That's the volume. And when we talk about surface area, we're thinking about wrapping paper. How much wrapping paper would I need to wrap it? So you're thinking about the outside volumes, the inside capacity. Surface area is going to be the outside. It's the area of all the surfaces. So we're going to start with a rectangular solid. So with a rectangular solid, like a box, the volume is going to be the length, the width, and the height. So the length and the width is making up what's that base, and then the height would be represented here. A cube is really similar. It would be length times width times height. So that base, but because all of the sides are the same, we could use S. So it would be side times side times side. So my volume formula changes just a little bit because all of the sides are the same. So side times side times side, which would be side cubed. So let's look at this. Maybe we have a block that measures 1 centimeter by 1 centimeter by 1 centimeter, and we want to find the volume. The volume is the length times the width times the height. So it's going to be 1 times 1 times 1, which is going to be 1, and my measurement would be centimeter cubed. And that measurement's going to always come out when you do the multiplication. So if we do 1 centimeter times 1 centimeter times 1 centimeter. We would multiply the numbers together to get 1, and then if we multiply centimeters times centimeters times centimeters, we would have centimeters cubed. So there's our formulas for the area of a rectangular solid, like a box, and we could tweak that to find the volume of a box. And we can tweak that to find the volume of a cube, where all the sides are the same. When we talk about a sphere, we're talking about a three-dimensional circular figure, so kind of like a ball. The diameter is going to go through the end point. It's going to go through the middle and it's going to touch the end. So here's my ball in 3 dimensions. So when I talk about that diameter, here's the center of the circle. Well, if it'll let me draw. And the diameter is going to go all the way through. So if I were to slice that figure in half and then look down, we're going to see a circle. If I were to slice a little piece out there, this would be my diameter. Has to go through the middle, touching both ends. So it would be that straight line there. You have to pretend that's a straight line. The radius is half of the diameter. So the diameter is made up of a radius piece on this side and a radius piece on this side. So diameter is 2 times the radius. So we've got this relationship going on there. So if I want to find the volume of a sphere, it's going to be 4/3 pi r cubed. So let's say we have an example. Let's say we have a ball that has a diameter of 8 inches. And maybe we want to find the volume. So we know volume is 4/3 pi r cubed. If the diameter is 8, then the radius is half of that, and half of 8 is 4. So my volume is going to be 4/3 pi times 4 cubed. So 4/3 times pi, and I have a pi button on my calculator that I'm going to use, times 4 to the third would be approximately 268.08, and that would be in cubic inches. So now let's look at a right circular cylinder. So with a right circular cylinder, the bases are going to be circles, and that height is going to be perpendicular to that base. So you can think about things like canned vegetables or canned soup. If we want to find the volume of a right circular cylinder, it's really just the base times the height. Volume for most of these will be base times the height. Since that base is a circle, we know that area of a circle is pi r squared. So then when we find the volume, it's going to be the area of the base, which is pi r squared, times that height. So that's where that volume equation is coming from. So let's look at an example. Let's say maybe we have a can of soup. That's 8 inches tall. And the diameter is 4 inches. Let's say we want to find the volume. So for us, if my diameter is 4, that would be the distance all the way across. Then that radius is half of that, which is 2. So my radius would be 2. And then the height would be 8. So volume is pi r squared h, which is pi times the radius squared times the height. And I'm going to plug that in my off-screen camera again. I have a pi button, so I'm going to use it. So that is about 100.53 cubic inches. So cones are going to be a little bit different. I want you to think about these kind of like an ice cream cone, like the waffle cones. These are going to be like this. So we're going to think about that radius again, and we're going to think about the height of the cone. So, and then L is going to be the slant height. So it's the height of that slanted side there. So to find the volume of a right circular cone, it's V equals 1/3 pi r squared h. Let's look at an example. Let's say we have an ice cream cone. That is 6 inches. Has that height. And a radius of 3 inches. Let's say we want to find the volume. Volume is going to be 1/3 pi r cubed times h. So it's 6 inches tall. So if I were to draw a picture of this ice cream cone, I'm saying this height here is 6. And then this time the radius is 3. And they gave us the radius, not the diameter. And so we would just multiply everything out, and that would tell us how much ice cream the cone can hold. Now, keep in mind, that's going to be what's inside of the cone, not any scoop that would go above the cone. So 1/3 times pi times 3 to the third times 6. So I got about 169.65, and that would be in cubic inches. And then we can talk about a regular pyramid. So the sides are going to be isosceles triangles. When we talk about an isosceles triangle, we're talking about triangles where two of the sides are going to be the same length. So an isosceles triangle would have these two sides the same, which kind of forces those two angles to be the same. And the height is going to be from that vertex, which is going to be that tip top of the pyramid, down to that base. So it's going to be that vertical height here, and they've just pulled that over to the side here. So the volume of a regular square pyramid, so notice that base is going to be square. That's why they have S's here and here. It's going to be 1/3 S squared times H. So notice that 1/3 happened with the pyramid and with the cone, but it's still area of the base times the height. Now let's look at a few examples. Let's say we want to find the volume of a cube that measures 1.5 meters on each side. So we're going to use our volume of a cube formula. So it's going to be side cubed, okay? And that's because every side is going to be the same. Let's see if I can draw a three-dimensional figure here. There we go. So each side is 1.5. So we have length, width, and height as 1.5. So this is going to be 1.5 times 1.5 times 1.5, or 1.5 cubed. And 1.5 cubed is 3.375, and that would be in cubic meters. Let's look at that next one. The radius of the base of a cone is 8. The height of the cone is 12. We want to find the volume of the cone. So let's draw a picture. So here's my cone. I know I'm using that cone formula, which is 1/3 pi r squared h. And they told us that the height is 12 and that the radius is 8. So that distance from here to here is 8. So we're going to have 1/3 times pi times 8 squared times 12. So I got about 804.25. And that would be in cubic centimeters. Let's say we want to find the volume of this oil storage tank. So we know it's a cylinder. It's 4 meters high and it has a diameter of 6. So if the diameter is 6, then the radius is half of that, which is 3. So volume of a cylinder is area of the base times the height. My radius is 3. My height is 4. So I have pi times 3 squared times 4, which is about 113.10. And this would be in cubic meters. if we wanted the exact, we could find that. 3 squared is 9. And we would say this is 36 pi. And that's still in cubic meters. So this is the exact. And then once we approximate pi, this would be the approximate. A lot of times when we're dealing with circles, we'll end up leaving it in terms of pi. And that is perfectly fine. So surface area. The surface area is going to be the total area on each surface, and we're just going to add it all together. So when we talk about a rectangular solid with length, width, and height, let's see if I can draw a decent rectangle here. So length, width, and height. And remember, this thing's going to have a base. It's going to look like this. So that base is going to have the same area as this. So it's going to be length times width. So I'm going to have this one and this one that's going to be the same, which is 2 times length times width. This side is going to have width times height as the area for just this piece, but this side's going to be the same thing. So I'm going to have 2 times width times height, and then if I look at the front and the back, I have a length, and then this is height h. So L times h would figure out the area of this face. And I have the front and I have the back. So if I add all of those together, that would give me the surface area, which would be how much it would take to wrap this box in wrapping paper. If we're talking about surface area of a cube has all the sides that are the same length. So let's see if I can draw a cube. And I am sorry that my three-dimensional drawings are not very good. So this side and the height are all the same. So that means every face is going to have the same area. So if you think about that, side face here is going to have a length and a width of S and S. And that's true for the front, that's true for the top, for both of the sides and the bottom and the front and the back. So there's 6 faces, and each face has an area of S squared. So that's why the surface area of a cube would be 6S squared. If we're talking about a sphere, surface area of a sphere is 4 pi r squared. If we're talking about a right circular cylinder, so think about like a can of green beans or something. So the top and the bottom are both circles. So the area of the top and the bottom would be pi r squared. So I'd have pi r squared for the bottom and pi r squared for the top, which would give me 2 pi r squared. And if you think about this, think about a can label. If you were to take a label off of a can of green beans and you were to spread it out, it would look like a rectangle, right? So we would know the height of that, but this thing wraps around that circle, which would be the circumference of that. And circumference of a circle is 2 pi r. I'll say C equals 2 pi r. So this length would go around that can, and that would be 2 pi r. So then the area of this unrolled would be around the circle times the height, which is 2 pi r h. If we're looking at a right circular cone, it's a little bit more complicated. It's going to be pi r squared plus pi rl. Remember, L is that slant height of that right circular cone. And then for a regular square pyramid, surface area is S squared, so area of the base, plus 2SL, where L again is that slant height. So let's look at a few examples. The diameter for the base of a cone is 5 meters and the slant height is 4 meters. We want to find the surface area of the cone. So the diameter is 5. So that means the radius is half of that, which is 2.5. The slant height, which would be this, is 4. So surface area is equal to pi r squared plus pi rl. And that's for this figure of a cone. So it's going to be pi times radius squared plus pi times the radius times that slant height. So this would be 6.25 times pi plus 10 pi, which would be 16.25 pi. That's the exact, and if we were to type that in our calculator, it would be approximately 51.05. And this is in square meters, because I'm squaring those units here, and then I would have the radius, which is meters, times the slant height, which is in meters. Meters times meters would give me a meter squared there. Let's do one more. Let's say we have a box. And here's my three-dimensional drawing again. And we'll say that box is 6 inches by 8 inches by 9 inches. And we want to figure out both volume and surface area. So volume, remember, is the length times width times height. So it's going to be 6 times 8 times 9, which is 432. And that would be in cubed inches, because inches times inches times inches. Surface area, you're going to think about the fronts. So the front of this box, if this side's 9, then this side has to be 9. So the front is this face. So it's going to be 6 times 8, and we have 2 of those. The front and the back are going to be the same height. I mean, they have the same dimensions. And if we think about this side, so this is front and back. So let's think about left and right sides. So this side would be 8 inches by 9 inches, but that would be for the right and the left. So we have 2 of those. And then we have the top and the bottom that are the same. So if this is 6 inches, then this has to be 6 inches also. And if this is 8, this would have to be 8. So that top is going to be a 6 by 8. So 6 by 8. And we have a bottom also that has the same dimensions. So we have 2 times 6 times 8 is 96. 2 times 8 times 9 is 144. And 2 times 6 times 8 is 96. Hold on, guys. I have 2 of these. I have made a mistake. Let's go back and fix this. This is going to be a 9. So if I look at this front, I actually read this wrong. That was a little messy. So that front is a 6 by 9, which means the back's going to be a 6 by 9 also. So 2 times 6 times 9 would give me that area of the front and the back. So that's what I'm adding together. 108 plus 144 plus 96. So my surface area would be 348, and this would be in square inches. So this box can hold a capacity of 432 cubic inches, and it can hold, it would take 348 square inches to wrap the entire box. So that's volume and surface area.